Assalamualaikum and hello everyone. We are from group 3 and this is our video proposal for experiment 4, saponification of ethyl acetate and sodium hydroxide in Cstr. My team consists of me, Muhammad Herman bin Ahmad, Muhammad Adam bin Zainuddin, Nadia Ashikin binti Mazlan, and lastly, Muhammad Amir Haikal bin Nazri Zulfakar. First and foremost, I will explain about the background of this experiment. The experiment is carried out to study the saponification reaction between sodium hydroxide and ethyl acetate. Saponification happens when the hydrolysis of fat that creates a soap in alkyne conditions. In other cases, saponification is happened by hydrolysis of an ester to form an alcohol and salt of an carboxylic acid. The experiment necessitated the establishment of the conductivity calibration curve using varying molar concentrations. Problem statement. To investigate the saponification reaction between sodium hydroxide and ethyl acetate with a Cstr and to comprehend how alteration in various operating conditions influence the efficiency of the reaction conversions. There are two main objectives in this experiment, which is to study the rate constant and reaction order of the saponification reaction between NaOH and Ea using graphical method and an analytical technique. Secondly, to study the effect of flow rate changes in the Cstr system. The scope of this experiment is to perform the saponification reaction between NaOH and Ea in a Cstr, involve the operational behavior of the reaction in a Cstr, and determine reactant conversion using conductivity calibration curve. Literature review. Saponification is a process that produces soap usually from fats and lights. In a technical term, saponification involves usually base NaOH, hydrolysis of triglyceride, which is an ester of a fatty acid, to form a sodium salt or carboxylate. Meanwhile, Cstr is a type of common reactor used in industrial processing, which is primarily used for liquid phase reaction. The reactor usually operates in a steady state condition with a continuous flow of reactant and product and assumed as a perfectly mixed.
Here is the apparatus and chemical use. 2 liter beaker, 1 liter beaker, 0.1 m sodium hydroxide, 0.1 m ethyl acetate, and Cstr reactor. And here is the experimental procedure. For the part 1, which is a calibration graph plot. Firstly, there are points were used to prepare conductivity calibration curve like this. Firstly, a 9-liter solution of 0.1 m NaOH and 9-liter solution of 0.1 Ea are prepared and poured into tank 1 and tank 2 respectively. Secondly, pump 1 and pump 2 and stereo were switched on. Thirdly, flow rates of the feed into the CSTR were adjusted to 50 cm cube over a minute using flow controller valves F1 and F2. Fourthly, the stopwatch was started immediately as the pumps and stereo were switched on. The conductivity and temperature in the CSTR were measured for every 2 minutes up until 30 minutes. Next, the space-time conductivity and temperature of the reaction medium were recorded when liquid level inside the CSTR reached 2000 cm3. The reaction flow into the buffer tank by opening valve 3 and the measurements were continued for 10 minutes. Valve F1 and F2 were closed after 30 minutes and pump 1 and pump 2 were stopped. Next, all liquids were discharged through valve V4. Next, the experiment was repeated with different feed flow rates at 60 cm3, 100 cm3, and 120 cm3. The remaining NaOH and ethyl acetate were discharged once the experiment were done. Lastly, plot plan was cleaned up. This is the analysis of this experiment. For the method to analyze result, we must use the conductivity calibration curve to get the linear equation. So, for the linear equation, we will obtain the y equal mx plus c. Y is the conversion value and x represents conductivity in unit micro as. Software to be used. We use Microsoft Excel to make a graph. And here is a calculation procedure. For the concentration of NaOH after the reaction, we use Ca equals Ca naught times 1 minus X. For part B, for the concentration of ethyl acetate, Ca equals Cb. For the concentration of sodium acetate, Cc equals Ca naught times X. And lastly, For the concentration of ethyl alcohol, Cc is equal to Cd.
Okay, so for the experimental plan for the 4.1 identification of data, table 4.1 shows that experiment data with the flow rate of 50 centimeter cubic per minute, 100 centimeter cubic per minute, and 150 centimeter cubic per minute. In the table, we have time for time, which is in minute, conductivity, temperature, conversion, Ca, Cb, Cc, and Cl. And for the time, we have for until 30 minutes. Okay, next for the 4.2, we have the outline of the plan. Before the experiment, preparation of lab, introduction is Herman, overall methodology is Herman, analysis, anticipated result Adam and Nadia, experimental plan reference Ame. During experiment, sample 1 is conducted by Nadia and Herman, sample 2 is conducted by Adam and America. And after the experiment, for the preparation of lab report, abstract discussion is due by America and Adam. Introduction is by Herman. Literature review, theory, methodology, Nadia and Herman. Result, conclusion, Amir and Adam. References, everyone.
Okay, next, we are moving on to the next part, which is anticipated result of the experiment. Okay, so basically from the experiment, we can determine the value of conversion, which is x, with specific rate constant k and average constant k average. After that, we also need to plot a few graphs of 1 over Ca, which is concentration of natrium hydroxide versus time at different flow rate, which is 50, 100, and 150 centimeter cube per min, in order to determine the value of average specific rate constant, K average, from the slope of the graph.